like Alessandra's filming.
Yes.
So whenever you're ready, Lisa, go ahead.
Hi everyone, today I'm going to introduce the role of calcium hydroxyapatite in dental enamel resistance. So growing up, have we all heard of the phrase, don't eat too much candy, it's bad for your teeth? Well, as a kid who was addicted to sugar, I heard of that thousands of times a day. So I'm always curious about how does your sugar deteriorates my teeth, and with this opportunity I explore teeth mineralization. How does your teeth dissolve, and how can we prevent it from dissolving? So why teeth have important anyway? So first, bad teeth will cause the digestive system issues and also respiratory system issues. And it will trigger all these kind of disease, and because there's also nerves inside your teeth, it will also trigger neural diseases like Alzheimer's. And the second is mental health. Bad teeth will lower your self-esteem, reduce social interaction, affect mental well-being because you're conscious of your teeth. So what really is your teeth? Basically, you can divide that into two parts, the root and the... Oops, sorry.
Sorry, I'll pause.
So basically, the root and the crown. So the root you cannot see, but basically it has all the nerves inside your roots, and then the soft tissues that anchors your teeth to the gum so it doesn't slip. And the crown is basically enamel. Enamel is the hardest substance in human body, and it cannot self-repair because it doesn't have any living cells inside it. And 96% of enamel is made by calcium hydroxyapatite, aka HAP. So now let's talk about teeth demineralization. So what happened basically is when you're consuming carbonated drinks or food like cereals, bread, milk, sugar, fruit, the bacteria on the surface of your teeth, like plaque and dental biofilms, they will absorb those sugar as much as possible, and because to nurture themselves, and then they will release different types of acid. They will release carbonated acid, they will release lactase, and then different types of acid. And those acids, they will dissolve your teeth. So how does those acid attacks enamel surface? So basically, acid is molecule with one hydrogen atom combined with some like really electronegative atoms, and then because of that structure, it's really unstable. So it wants to get rid of the hydrogen. So what you usually do is it combines with a lone pair with the other molecules, so they can get rid of that hydrogen. In the teeth scenario, for example, for the carbonated acid, we can see there are like hydrogen atom hanging over here, and then this is the structure for calcium hydroxyapatite, and then there are lone pairs. The hydrogen usually combine with calcium and phosphate ions because you can see there are lone pairs over here. So those are the examples. So this is basically the calcium hydroxyapatite, and then this is the citric acid, which is 3H2, and then those are the aqueous that it will turn into. And the same for this one, the calcium hydroxyapatite, another different type of acid, and the aqueous, including water that we're familiar with. Oh, one more thing. So basically, this reaction can be called acid-base reaction, where the acid is the acidic saliva in your mouth, and the base will be the teeth. So those are the graphs for the pH of different acid and also the drinks. So you can see they're like mainly like carbonated drinks and fruit juice. So how does that one hydrogen atom affect your teeth? So basically, pH doesn't affect it, like your teeth dissolution at all. But the main factor is QSP. When the QSP drops lower than the KSP, then the teeth will start dissolving. So KSP is a solubility product constant when solid dissolves. So the way to calculate that is the concentration products of the products over the concentration of the reactants. And then because calcium hydroxyapatite is crystallized mineral, so the concentration will just be 1. So that's how we derive the KSP, and it's usually a set value for different minerals. And QSP is a solubility product quotient or ion product. It can be the concentration of any stages of reaction. Unless KSP is only when the equilibrium is achieved. And then the same equation for QSP. And then how does that one hydrogen atom affect? Is you can see the hydrogen atom when you add that into the enamel, then you will need to times the hydrogen, like the concentration of that one. And you can see it's really usually extremely small. It's 10 to the negative pH. So when you times something really small, you get like a smaller QSP. And then when the QSP is equals to KSP, there's no gain or loss of the ions. And then when QSP is lower than the KSP, your crystal will start dissolving. In this scenario, it's your teeth. And then when the QSP is bigger than the KSP, the crystal will grow into a supersaturated state. So now let's talk about teeth remineralization. So there are three, but not limited to three ways. The first is saliva. Like your own saliva will kind of like neutralize the acids. Well, if there's like proper amount of acid. If it's too much, your saliva cannot do the job. And then the second is the change of diet. If you reduce the amount of carbonated food or sugar that you inserted in yourself, then your teeth will be healthier. And then third is mainly I'm going to focus on is the fluoride. So to understand fluoride, we need to know where like all these reaction happens. So as you can see, the small like crystallized like teardrop shape, those are one unit. It's called the rod of the enamel. So that forms your whole enamel, and you can see like teeny tiny gap between the rods, and then those it's basically right here, and then the acids they will enter the gaps between the rods and then or fluoride, and then they will do their work there. So okay, we need to introduce one more concept, is Coulomb's law. So what Coulomb's law saying is all the ions, they're connected by the electrostatic force. So this is the equation for it. As you can get from the equation, if the distance is closer between the charged ions, then it will have a greater force to attract them, and then it's harder to pull them apart. So what fluoride basically does is fluoride has a smaller, fluoride is a smaller molecule than OH. So there will be more fluoride fit into the gap between the rods. So if there are more fluorides fit into it, they're more it's more denser. So they're closer to each other. So the distance will reduce, and there will be greater force. So that's how fluoride it's can prevent from the teeth demineralization. So another aspect to look at is the solubility and polarity. So basically when the hydroxyapatite dissolves, they became all these aqueous, and because it's equilibrium, so it can go both ways, the reaction, and then when fluoride is present, it will go that way, and then it will form fluoroapatite, and then you can see it's basically the same, but the fluoride replaced the hydroxide. So fluoride is nonpolar, and then hydroxide is polar. So when the liquid is polar, right? So the fluoride will be less soluble than hydroxide. So that's how it's fluoride is less soluble than it, so it's harder to demineralize it. Last aspect is KSP. The KSP for fluoride is 5 times 10 to the negative 123, and then the KSP for HAP is 5.5 times 10 to the negative 181. So you can see it's significantly smaller than HAP. So it needs a lower QSP, so it needs a lower pH, and it needs a lower it needs more acid. So you need more works to dissolve fluoride. Okay, now let's talk about the bad side of fluoroapatite. So fluoride, if you consume way too many fluoride, then it will cause fluoride toxicity, and then you will have dental fluorosis, which is the white spot on your teeth, and then they're permanent, so you cannot really remove the white spot. And however, after asking a lot of dentists, well, their opinion is basically fluoride is everywhere. 70% of the world is consuming fluoridated drinking water. So if you have a little bit of fluoride, then it probably wouldn't really harm that much, as long as you don't excessively consume. So moving forward, I believe we need to raise awareness on dietary choices, proper amount of fluoride, and always be on your dentist appointment and always brush your teeth 2 times a day for 2 minutes. Thank you. Any questions? Yeah, Lear?
Are there any other applications of fluoride in like toothpaste?
So basically, you can access fluoride the most normal way is the toothpaste, and then by the end of your dentist appointment, if you tell your dentist like don't put fluoride on top of teeth, usually they will brush like a thin layer of fluoride on top of your teeth, and to like enhance your teeth quality. Any questions? Okay, thank you.